Cool. Thanks for bearing with us, everybody. Look, last talk of the day. We've heard a lot about AI and LLMs and all that today. But as well as giving maybe some of us who've been around the industry a while a new approach to this, we've also seen some exciting new startups in the last year or two. And look, I'm delighted to welcome Asim here from Reworkd AI. They're one of the guys who are really innovating in this space. And yeah, look, excited to hear about what you're doing.
Awesome. Thank you so much. Is this working, sorry? OK, perfect. Yeah, hey, everyone. First of all, thanks so much for joining me here today, especially given we're at the very tail end of the event. My name is Asim, and I'm one of the co-founders of Reworkd. At Reworkd, we're working on multimodal. Is this working correctly? Yeah, we're working on multimodal LLMs to parse and understand the web and generate code to extract both unstructured and highly structured web data for our customers. And there seems to be some weird artifacts. And so, though we've been working within the web data space for quite some time now, we've more broadly been working with LLM agents for even longer. And in early 2023, we created one of the first generally available general-purpose LLM agent tools, and we quickly saw a tremendous amount of traction. And so this product had over 1 million users. It had over 30,000 stars on GitHub. And from there, we went through both Y Combinator and the AI grant. And we also went through a really long period of experimentation across many different domains and many different LLM products before ultimately arriving at where we are today. And so this is all to say that we think we've gained a tremendous amount of experience in working with these models, evaluating them, and tuning them. And we're excited to hopefully distill this down to some of you here today. And so the talk itself is going to be broken down into these 3 key sections. One is just thinking about the user interface for LLMs, and we'll go over how to best define the interface that you expose to these models so that they can best understand the state of the problem and build a solution. Second, we're going to take a very pragmatic look at how to think through prompt and flow design. And so when you have an LLM product, you want to understand what are the things you can do to increase your engineering rigor and get performance up to production standards. And finally, how do you evaluate everything? How do you verifiably show that these things work? And how do you verifiably show that they work over time? And so the hope is, regardless of whatever domain you operate in yourselves, you'll have some high-level techniques that you can apply into your own products. And so the first is LLM user interfaces. And so as we build these LLM products, we need to connect them to these external systems. And we need to expose the functionalities of these systems to our LLM. And so in some cases, it can be pretty simple. If you're dealing with just an API, for example, you can pass in the specifications directly, and the model can very easily select the best parameters to call this API with. But for more complicated use cases, you have to be a bit more clever. And so one key area where we needed to be a bit more clever was in web page parsing and web page understanding. And so for us as individuals, when we're looking to get web data, our interface is a mouse and keyboard, it's a browser, and this seems to be pretty optimal for us. But these aren't really the modalities that LLMs best operate in. And so how can we expose the state of the browser? And how can we expose the same action sets that we as individuals would take on a mouse and keyboard? And so we, of course, first got the obvious out of the way. I guess raise your hand here if you've ever tried just sending raw HTML to an LLM and trying to get a response. Cool. Yeah, a bunch of you here. And if you're here at the lab yesterday, that's exactly what you did. And what's surprising is that this actually works well. And through the HTML alone, the models are able to find these very specific fields that you're looking for. And what's even nicer about HTML is that it has all the context to either extract the data directly or generate code to extract this data. But just using the raw HTML itself is a bit naive. Even in this example, we can trim the context quite a bit. There's things like script tags or very long attributes. But regardless of these optimizations, what we quickly found was that this approach has its clear limits. With large web pages, the context length is either broken or the page itself becomes way too ambiguous for a model to operate in. And there's also a large class of problems where HTML alone just can't solve it, right? So if there's things like elements stacked on screens, if there's stuff like modals or pop-ups, just using HTML alone is not robust enough to handle these situations. And in a lot of ways, it's kind of intuitive why it's not the best approach, right? So if you look at this HTML, I don't think anyone here can really understand what's going on or really understand what page this actually is. And you'd be surprised to know that this is actually the Google search homepage, right? But just through the DOM alone, it's very difficult to see for us. And if it's difficult to see for us, probably it's difficult to see for the model as well. And so a more concrete reason why this is difficult is because of the fact that web pages are designed to be visually consumed. And so if you take a look at this Amazon job posting, there's a lot of visual cues within the layout of the page to describe exactly what's going on, right? So if you look at this Apply Now button, we can understand through the contrast of the color of the button and the background that it is a link, perhaps. We can understand that like the sections at the top are headers, and there's like a filter menu based on the icon. And we know that on the side there is this sidebar. And so this is why we were very excited when GPT-4 Vision came out, because now we could just arbitrarily pass in this screenshot and directly extract this data. And it can also deal with the issues we had before with modals and banners and stuff like that. But what was easy with HTML now becomes a bit harder, right? So before, when you had the direct HTML context, stuff like that Apply Now link, we could directly extract elements from the HTML, like the href. But now all the LLM can respond with is like, hey, use the Apply Now button, which for us isn't very helpful. We need a way to actually reliably map that response back into the underlying HTML. And so to handle this, we developed this open source annotation library called Tarsier. What Tarsier will do is visually tag the interactable elements on the page by adding these annotations beside them. And so in the same example, you can see now that the Apply Now link has this annotation to the left of it that just reads the @ symbol and 10. And so this does two things. First, the @ symbol tells us that this is a link as opposed to a button or as opposed to an input element. And this 10 is this unique identifier we have for this element. And so now when the model wants to select for this Apply Now button, instead of saying, hey, use the Apply Now button, it would tell us directly to use the model with ID 10. And we can map that back into the underlying HTML. And so this was another step in the right direction. But at the time, vision language models were still too early. And even today, they're still not as performant as we'd like to be. And they suffer from a lot of issues of text misinterpretation that just pure text LLMs don't have. And so this might mean that it reads content on the page incorrectly. And even worse, it may actually misinterpret some of the IDs that we've tagged on the page. And so instead of the number 10, it might return the number 15, which is completely unrelated to what we want. And so through all these experiments, we wanted to really combine all of what we found to work best. And so we wanted to know how we could harness the power of just using a pure text approach, how we could make it really easy to retrieve the underlying HTML elements, and how we could actually still capture the structure and layout of the page. And so this is when we developed this sort of 2D rendering algorithm that ended up working incredibly well. And so it uses OCR to convert that exact same page into this white space structured string that an LLM, even without vision, can very, very easily understand. And you can see now we're just using text-based LLMs, which is where it's best. You can still see the underlying structure of the page. You can still see that there's a sidebar. And you can still see that that Apply Now section is a button because of that @ symbol and that ID. And because of the tags, we can still retrieve the underlying HTML elements. And because of all this, our internal benchmarks actually increased in performance by over 20%. And so being clever about the interfaces that we use to send to these models really went a long way. And there's a lot of opportunity to apply these ideas of clever interfaces across the whole stack. Cool. And so now the next section is prompt and flow design. So after you have an initial prototype developed for the system, what are some of the engineering practices you should undertake to actually build on performance over time? And so there's a host of standard techniques with dealing with LLMs. And so surprisingly, even though they are quite simple, they still work very well. And so you're probably familiar with them to some extent if you're a developer, but I'll go over them anyways. And so first is a small prompt change, like using chain of thought or the React framework. And what this basically entails is just asking the model to start responses by explaining its logic step by step before actually returning an answer. And the idea here is just as a human might think through a problem before we talk about a solution, the models can do that as well. And surprisingly, it works very well. And this is sort of the framework that the new O1 models from OpenAI are also using. Another technique is just using structured outputs for all of your responses, which means that you can deal with objects and classes in your code as opposed to just natural language strings. And a lot of LLM providers today actually provide this as first-party features in their APIs. But there's also a lot of libraries that you can use to inject this behavior into your responses, like Marvin, which was touched on yesterday, I believe, and also Instructor. And this really improves the developer experience when you're working with these language models. And the final basic technique is to really heavily optimize the context that you're passing into these models. This was talked about in the last talk as well, but everything you pass in has a strong impact on the response quality. And outside of a select few use cases with LLMs, regardless of the context length that the LLM model accepts, if you put in a bad context, you're going to lead to very bad responses. And so this was, again, one of the issues with just passing in the raw HTML is that there's a lot of useless context that kind of pollutes the overall response of the model. And for sort of a higher level technique that we use is this idea of flow engineering. And so a lot of the existing agent systems today boil down to this idea of freely providing LLMs with access to a wide array of tools, giving it a high-level goal, and then setting it free in a loop. And so while those are really good for some basic demos, it very quickly breaks down in production use cases. And so what you want to do is first be extremely specific in exactly what kind of flow your LLM is attempting to capture, and then emulate exactly that. And so what we did was take the approach of mimicking our own manual process for extracting web data. And so for us as humans, what we do is we'd go to a browser, we perceive the page, we test out different selectors and different approaches, we're executing and evaluating code, and then we're validating and fixing any issues as they arise. And so once we understood what this flow looked like at the high level, we could build features within our systems to very discreetly and very specifically handle each of these steps, as opposed to letting the LLM just freely decide on what to do. And so how it works for us is we have a very specific page understanding portion, we have a very specific experimentation and exploration portion, and we have a very specific code generation portion, and so on. And what's nice is when you have these very individual steps, it becomes easy to add domain-specific optimizations into each of them. And so as mentioned, we have this code generation step. When we first started this project, we were just executing raw playwright code that the model generated. But one of the optimizations we did was instead of doing arbitrary code, we constrained it to a very specific SDK function, which ended up greatly improving performance. And so how it did that was we now had control over some of the abstractions that the model was using. And so we could take away the complexities of having to deal with schema validation, having to deal with saving data into our internal system. And the model could instead focus on finding quality selectors. And then we've also done a lot of work at the AST level itself. So once this function's been defined, going into the AST and actually we're using async Python code, and so adding awaits where it was missing, actually testing out the selectors that it selected and optimizing it if there was any issues. And all of this accounted to a lot of great performance improvements for us. And so finally, and maybe most importantly, is the topic of LLM evaluations or evals. And what evals are tests you run covering a real-world use case. And so it contains both the input pair, to which might be the state of a website, and the output pair, which is the expected underlying data. And what it does is help you verifiably demonstrate the current state of your LLM performance. And running evals is really the only way to build performance and actually iterate on bottlenecks over time. And so we just talked a bunch about some prompt optimizations and LLM UIs, but the difficult part is when you're working on those things, just changing a single line in a single prompt can have like really, really disastrous impacts on your performance in a wide array of use cases. And creating and running evals is really your only way to combat that. Specifically, it's important in what we do because the web kind of sucks. And it is the world wide web after all. And what I mean by that is that there's standards that aren't standards. There's hundreds of frameworks. There's hundreds of style systems. Every now and then you have to deal with this fully JavaScript web page that's over 20 years old. And what this leads to is this huge diversity in the state space that these models have to operate in. And so even if you're looking at very similar seeming e-commerce websites like Amazon or Walmart, the approaches you have to take within them are extremely different. And so you need to be able to handle it all. And not only that, you need to be able to prove, and the only way to prove you can do that is through evals. And so how exactly should you be creating evals for these websites? It'd be amazing if we could just go to these websites, run our tests live directly, and then do it across every PR, which is known as online evaluations. But to do this, you hit all the issues that you would with any normal scraping job. Things like the network latency make running tests pretty unbearable with the delay. Pages are going to change over time and break what the expected data ultimately is. And if you run these tests long enough, you're going to be hit with CAPTCHAs, and you'll just ultimately be blocked by the website itself. And so you don't want to be buying CAPTCHA solvers and buying proxies just to run your test. In academia, there's a lot of existing research on these ideas of simulated web environments to do more and this is called offline evaluation. And so there's papers like WebShop and WebArena. And what these do is mimic these existing websites like Reddit or Amazon in a very fully simulated environment. But they also have quite a few problems. Again, they lack diversity. The web is extremely diverse. Just having a few samples of simulated websites just isn't enough to see all of the complexities that is on the internet. 2, they're very difficult to make. Someone has gone in and manually engineered these websites, and you cannot just do this at scale you can't do this at the scale of emulating the entire web. And finally, they're very limited in action space typically. Because they're manually made, these sites end up being quite simple, and they also really don't let you do things outside the scope of what is expected in a given test. And so if a test expects you to go to a detailed page and click checkout, there may be other actions on the page that just don't work whatsoever. And so when we sat down and when we thought about evals, we built sort of the 3 following criteria. 1 is that they needed to be static. We should never have to deal with pages changing over time. We should never have to deal with the network, proxies, bot detection. And this means that online evaluations just wouldn't work for us at all. 2 is that they needed to be diverse. We needed to hit every single page type possible, which meant that these existing simulated environments just wouldn't work either. And finally, they needed to be as domain specific as possible. The existing data sets, again, would be testing use cases that were completely outside the realm of what we wanted to do as a company. And so we needed something very specific to data extraction. We needed something very specific to the websites that our customers might actually go to. And the only way to do this was to do it ourselves. And so that's what we did when we made this open source repo called BananalLizer. We have this thing where we name everything after some monkey-related stuff. You can talk to me after the conference if you're interested in hearing about that. But what this is a library on top of Playwright that does 2 things. 1 is that it's the collection of all of the input-output pairs that I mentioned earlier. On the left is a concrete example of this. We have metadata like the ID, the source where the URL's from, some categorization info, and then ultimately the data that's expected to be scraped from this website. And then we also collect a frozen version of these websites itself so that we can repeatedly and reliably revisit this page. And again, this page is like an actual live website on the internet that us or a customer has gone on at some point in time. And then the other part of BananalLizer is the actual testing logic itself. It'll generate PyTest test files automatically for each of these examples. It will instantiate browser instances. It'll pass this off into the client code that will actually run this agent system. And then ultimately, it'll validate results in a very fine-grained way so we understand exactly which fields are missing, which fields are incorrect, et cetera. And so we run these, as a company, we run these evals many, many times every single day across every single PR. And we're very, very serious about having this sort of eval-driven approach to development. So much so that for the first couple months of starting this project, my co-founders and I just sat down and we hand wrote evals for weeks on end. And it was this very grueling, painful process. But I'd recommend everyone do it just because you gain such a good understanding of everything that's required as part of this entire product. And so once you've built an understanding of exactly how your eval stack should work, though, the final step is, of course, to make a flywheel out of this process as a whole. And so thankfully, today, our co-founders are not manually writing this stuff anymore. We have a system where you can dynamically generate it based on the actual usage of our product. And so this has been really helpful in the sense that you can create evals for these specific edge cases that you aren't currently handling. You can now work on these new interfaces or these new prompt design changes to actually be successful in these use cases. And then again, you can create more evals and have this flywheel effect. And so cool. So with that, just want to show a very quick demo kind of collecting all of that stuff together and how it's exposed in our product today. we'll be using one of the example Zeit websites, which is just this books to scrape website. It's sort of a standard e-commerce page, and we'll look at these fields, including stuff like the title, quantity, availability, currency, stuff like that. And so, yeah, we have a quick video because I was not brave enough to do it live. But once you hit run, a lot of what I mentioned is happening in the background in terms of this page understanding process, rendering of the browser, annotation of the web page, and then this goes through the pipeline. And sorry for the flickering, but it goes through the pipeline, and then you can see sort of the reasoning traces of the model as it tries to understand how it should best approach each individual field within the schema. And then eventually it's generating this code following our SDK functions to retrieve each of the fields that we wanted it to retrieve. And eventually it'll use, again, the SDK functions to save this data. This video is just a bit sped up for the sake of this demo. But then there's a whole validation process. There's a whole process of optimizing the code via the SDK that I mentioned. But the end result of having done all of this will be just a piece of code that you can rerun on this given website, and then ultimately the underlying data that's present on the page. So you can see stuff like the title that was there before, descriptions, etc. Great. And so that was a really high-level look at what we do. To end off, this is just a look at what I think should be some of the main takeaways. And so one, of course, is being as domain specific as possible, constraining the scope of your product, constraining the scope of each LLM step that you have, constraining the scope of your evals, because there's so much diversity in the problem space that you'll have to face that you just need to simplify it as much as possible. 2 is emulating your own flows. So you learn a lot just by concretely codifying everything you would do as an individual, and then you can perform the step of translating that into an interface that works well with these models. And 3 is evals. I think if there's any one thing to take away from this talk, it is just the importance of evals. It's really the only way to understand whether or not things work, whether or not, like, why things fail, and how to keep things working over time. And then finally is building this flywheel and having this sort of iterative process where you can use your evals to shape your product direction, and then your product direction will go back into your evals to validate whether or not it works. Yeah, if you're interested in learning more about our company, you can head over to our website, Reworkd AI at the top, or you can use the QR code on screen. And if you're interested in talking to me about anything we went over today or anything in general, feel free to just email me directly. And so, yeah, that was a slice of what we do in a nutshell. Thank you, everyone.
Cool. Any questions from the audience? No, I think everybody's a little bit tired after today. But that was a very exciting talk. I really enjoyed it. Thanks very much, Asim.
Awesome. Thank you.
So look, as we're wrapping up, just a couple of reminders. 1, please fill out the survey. You'd all have received it in your email. We appreciate, I thought the talks this year were great, but we really appreciate people submitting talks. So you've got a year to prepare for it now, so please submit for next year. Join the Discord community. We'll stay connected. We'll run other events, smaller events throughout the year, many of them virtual. We're going to make the recordings and slides available to everybody after this session. And look, I just want to thank all the speakers. They were, I think they get better every year. And we've made a donation to Skill Point Alliance as a thank you for speaking. That's a local charity that offers free fast training in skilled trades and manufacturing. So thanks to all our speakers. And I just also want to give a big shout out to the Zeit team who organized this. It's nobody's day job. They did a great job organizing it. So thank you. And for everybody here on the day, there's drinks out in the terrace and food will be served shortly. So thanks, everybody.